Thank you. Everyone, please stay muted. I have not targeted a hard mute. Okay. So here, there are 3 rules. This is part of Rosen, the book that is already being shared. It is also available in the library. Okay. So just give me a second. Yeah. So the first rule is product rule. Effectively, what that means is if you can do a task in a tree-like manner. Okay, so for example, this process can be divided into this process can be divided into the task 1. Yes. Guys, if you keep joining in late, it is becoming extremely difficult to keep admitting people. Okay. Now, so yes, Shomudeep, I am Oshmita ma'am only. That is what I am saying. Those of you who are regular students, okay, who have already done this part in class with me, there is no need for you to be in class doing this again. You can be here if you want to go through all of it again, but it is not mandatory. Okay. This class is especially for the lateral entry students, especially those lateral entry students who have joined like really late. Therefore, they've missed the initial classes. Okay. So starting the topic. So the first is the product rule. Okay. So the product rule is basically if a procedure can be broken down into a sequence of tasks, matlab you are doing the task one after the other, not together. You have to complete the first task and then only you can move on to the second task. So if a process is broken down into a sequence of 2 tasks, where the first task you can do in suppose n1 ways, and for each n1 way, the second task can be done in n2 ways. Then the total number of possibilities is n1 into n2. Basically, the idea is like this. So if we have a sort of like tree-like way, suppose, of doing the task. So suppose this is task 1 and you can do it in 2 ways. Okay. And then there is task 2. For each of task 1, you can do task 2 in suppose 3 ways. So you have this tree-like structure which is drawn on the screen. So then if the question is, in how many ways can you do the task, the entire process, then you will obviously say 1, 2, 4, 5, 6, which is effectively 2 into 3. So this is product rule. Okay, when there is a process which can be broken down into a sequence of 2 tasks. You do the first task in n1 ways, and for each of n1 way, you can do the second task in n2 ways. Then the total number of ways in which you can complete the entire process is n1 into n2, which is what I have. So effectively, whenever for a problem, you can represent it as a tree, like the one I have drawn on your screens. Then you apply product rule. Now, for practical purposes, what you guys need to remember is for product rule, your keyword is going to be the word and. So if you describe a process and you find yourself using the word and to describe it, then you know that this will be under product rule. So and equivalent to intersection in set theory, here gives you product rule where you're supposed to multiply. A very simple example being, suppose you've gone into a movie hall and you have to count the total number of seats in the movie hall. Okay. So the idea is that we first count the number of rows in the hall and then how many seats are there in each row. So your entire process is counting the total number of seats in a movie hall broken down into a sequence of two tasks. First task is you count the number of rows, and then the second task is for each row how many seats do you have. So suppose if there are 10 rows and each row has 20 seats, then you will immediately say the total capacity of the movie hall is 10 into 20. Okay. So this is a very simple, straightforward application of product rule. Similarly, suppose if I say, suppose you have a 3-character alphabet. Suppose you have a 3-character alphabet and you can have 3-character alphabet password only, not alphanumeric, only alphabet password, uppercase. So then what you can do is, so we can have a picture like this then. It means that it therefore means that you have 3 places or 3 boxes, and each box you can have 26 choices because there are 26 English uppercase alphabets. So if I describe this process, then I will say that there are 26 ways to fill up the first box, and there are 26 ways to fill up the second box, and there are 26 ways to fill up the third box. So notice I'm using the word and to describe the process. 26 choices for the first box and 26 choices for the second box and 26 choices for the third box. And therefore, the moment I have used the word and, as I have already explained, we are going to multiply. So your answer is going to be 26 into 26 into 26, which is 26Q. Okay. So whenever while describing a problem you find yourself using the word and, then you know that you have to apply product rule and you have to multiply. Okay. A number of examples are given in the notes, so you can go through all of these examples. The second rule is, so here as you can see all of this is given, so you can just go through the notes quickly. Now the second rule is sum rule, and here the keyword, like in the previous case the keyword was and, here the keyword is or equivalently stands for union in set theory, and here or sum rule would be addition, plus we will be adding the values. So if you can do a task in n1 way or in n2 ways, not and, or. It's either or. So you can do a task in either of n1 ways or in either of n2 ways. Then the total number of ways of doing the task is n1 plus n2. Here the restriction is that these n1 ways and n2 ways, there are no common ways of doing the task. There is no overlap. The same rule, the more general version of the same addition rule is this subtraction rule, also known as the principle of inclusion exclusion. This is, however, not the general rule. Yes, Adnan, I have had spoken to Joydeep. The point is he has to join with a new ID. He has to join with a new ID, otherwise he will not be able to join. Okay, I've told him that. Now, So what the subtraction rule say, it's almost the same statement as addition rule, which is there are n1 ways of doing the task or there are n2 ways of doing the task. The difference is between addition rule and subtraction rule is in case there is some common way, matlab between n1 ways and n2 ways, there are certain number of common ways. So what happens is if I then add simply n1 plus n2, then those common ways are being double counted. So for example, very easily understood if I draw. So this is your set of n1 way and this is your set of n2 way. So this is the common. So if I now say the total number of ways of doing the task is n1 plus n2, effectively what I have done, I have overcounted this shaded part. I have double counted it under n1 and under n2. So therefore I have to subtract the number of common ways. Okay. If there is no intersection, then it is addition rule. Simply n1 plus n2 because this minus number of common ways is 0 effectively. So you will get n1 plus n2. But if there are common ways, then to prevent double counting, we have to subtract it. This is basically very similar to what you've done in probability. P of A plus B is PA plus PB minus P of AB. So effectively, that arrives from this principle. Okay. So when our keyword is or, there are no common ways, then it is addition rule. If there are common ways, then it is subtraction rule. Okay. Again, as you can see, a number of ways are, a number of problems are done here. So you can go through those problems and then if you have trouble following them, you can get in touch with me. Achha, just to clarify, division rule is not part of your syllabus. So the division rule which is included in the note, that has not been taught in class. So you do not need to study that. Okay. 3 rules of counting are only included in the syllabus: product rule, addition rule, and subtraction rule. Now, next, topic 2 is pigeonhole principle. Topic 2, pigeonhole principle. What does pigeonhole principle say? If k is a positive integer and k plus 1 or more objects are placed into k boxes, then there is at least one box containing 2 or more objects. I'll just show you quickly with the help of an example. Suppose we are looking at this question. Okay, we are looking at this question. So the question is, among any group of 367 people, there must be at least 2 with the same birthday, assuming it to be a leap year. So what does it mean? So suppose it's a leap year, meaning there are 366 days in a year. And in my group, there are 367 people. What is the worst case scenario? The worst case scenario is everyone has a different birthday. So January 1 is my birthday, January 2 is your friend's birthday, January 3 is another friend's birthday. So what I'm doing, I'm saying whoever's birthday it is, I'm putting that name on that day. Okay, so January 1 is assigned to me, it's my birthday. January 2 is assigned to you, it's your birthday. January 3 is assigned to your friend, it's his birthday. Like that. What is the worst thing that can happen? I will assign 366 people to 366 days. Everyone has a different birthday. But there is one more person left. There were 367 people in my group. So there is one more person left. So what happens then? So what happens is, if you notice, whichever day of the year is his birthday, if I map him to that day, for example, suppose his birthday is today, okay, it's 6th August. So I put his name across 6th August, but 6th October, So 6th October had already been assigned to someone. So now I have one day, which is 6th October, which happens to be the birthday of two people. Okay. So so pigeonhole principle, what does it say? It says that if there are K boxes, I'll write on the screen. If there are K boxes, so suppose your box is your day. So you have K boxes, matlab you have 366 days, provided it's a leap year. And you have K plus 1 objects. K plus 1 objects, matlab us, people. So number of objects is at least one more than the number of boxes. Then there will be at least one box where there will be at least two objects. Okay. Again, for example, suppose you have 4 boxes and you have 5 apples. So what I can do, I can put 1 apple each in the 4 boxes. So 4 apples are taken care of. But what happens to the 5th apple? I have to put it in some box. So the moment I put it in any box, that box becomes at least one box has at least 2 apples. Okay. So this is pigeonhole principle. Now this principle can also be extended. This principle can also be extended to something called generalized pigeonhole principle. What does generalized pigeonhole principle mean? Generalized pigeonhole principle means that instead of K and K plus 1, if I say now that I have N objects and K boxes where N is greater or equal to K plus 1. Okay. So now number of objects, there is no restriction that the number of objects has to be only one extra. That restriction of pigeonhole principle where number of objects can only be K plus 1. Number of objects can only be K plus 1. That restriction is now removed. Number of objects can be N when N is greater or equal to K plus 1. This is generalized pigeonhole principle. So if this happens, then what is the statement? Then at least one box will have at least ceiling of N by K objects. At least one box will have at least ceiling of N by K objects. What does this mean? So suppose, for example, taking that apple wala example only, suppose I have 4 boxes. I have 4 boxes and I have 10 apples. So not 5 apples. If I had 5 apples, this would be normal pigeonhole. But I have more than 5 apples. I have 10 apples. So this is generalized pigeonhole. Okay. So what can I do? So what would the statement be? At least one box will have at least ceiling of 10 by 4 apples. What does this mean? 10 by 4 will give you 2.5, right? Ceiling of 2.5 means the smallest integer greater than 2.5. So after 2.5, what is the integer you have? Smallest integer greater than 2.5. So 3. So generalized principle will tell you here that at least one box will have at least 3 apples. Okay, at least one box will have at least 3 apples in case of generalized pigeonhole principle. Okay, now again, as you can see, small examples of pigeonhole principle and then small examples of generalized pigeonhole principle are given in the note. Please go through the note, and in case you have any queries, then you can get back to me. However, example 7, example 8 on your screen, as I'm showing you on your screens now, example 7, example 8, and example 9. These three examples are out of the scope of your syllabus. These are much harder problems, so you do not need to study them. Okay. So under generalized pigeonhole principle, please study until example 6. Examples 7, 8, and 9 are not part of your syllabus, are not meant for you. Okay. So this is topic 2, pigeonhole principle and generalized pigeonhole principle. Next topic is basically permutation combination. Yes, Aruni, all of these examples are available in Rosen. I have told you repeatedly because that is your reference textbook. So then I followed that only, because I have told you that you should study Rosen. So therefore, all the problems that I have discussed in the note, we have discussed other problems in class. You understand, but I can't take you through all the problems right now. So please go through the solved examples of Rosen and the exercises. Do not attempt the really harder questions for Rosen. The first part, maybe the first 50% of the exercise would be good enough for you. Okay. Now coming to permutation combination, I'm not going to discuss permutation combination. There's nothing there new for me to discuss. All of you already know permutation combination right from school. So NCR and NPR is not something that I'm going to discuss. What I'm going to do is I'm going to go straight into generalized permutation and combination. Okay. So generalized permutation and combination, it means permutation combination with repetition. Matlab where repetition is allowed. Usually when you solve permutation combination questions, for example, a very standard combination question is suppose there are 10 people in a class and I have to make a group of 5 people. In how many ways I can do that? And you will say, ma'am, it's going to be 10C5. There are 10 people and I have to choose 5 people. So it will be 10C5. Okay. So that obviously there is no repetition here. I cannot repeat a person, right? So that is normal permutation combination where repetition is not allowed. However, generalized permutation combination, repetition is allowed. Okay. So for generalized permutation combination, what happens when we allow repetition? Now, just give me a moment. Yeah. Yeah. So coming to generalized permutation and combination, please note that for your MPA part, I have not covered Pascal's triangle, Pascal's identity, binomial theorem. That part I'll come back later after your MPA. So that part is not included. After permutation combination, please go straight away to generalized permutation combination. Okay. Now, so permutation combination with repetition. So what is permutation with repetition? Let's take that example only. So suppose if I say in how many ways can you arrange 10 alphabets, suppose in how many ways can you arrange 10 alphabets taking 4 at a time without repetition, then your answer would be 10 permute 4. N objects taking R at a time, permutation is NPR. So 10 permute 4. What happens if I allow repetition? So what that does to the problem is, so for example, now I have 4 places, repetition allowed. Again, I'm going back to the first password wala example that I used at the beginning of the class. Suppose I have an alphabet only password, uppercase. Repetition is allowed would give you again as I discussed in product rule, 26 choices, 26 choices, 26 choices, 26 choices. I will be using the word and. So therefore, you're going to tell me it's going to be 26 to the power 4. So this is basically permutation with repetition. Okay. For the same question, if repetition was not allowed, then you would have given me the answer 26, 25, 24, 23, which is effectively 26 permute 4 without repetition. So without repetition, the one that I have boxed on your screen, without repetition, if the same question was in how many possible alphabets can you have when you are not allowed to repeat the alphabet, you would have said, ma'am, it's going to be 26 into 25 into 24 into 23, which is effectively 26 permute 4. What happens if I allow repetition now? If I allow repetition, then this is your answer, 26 to the power 4. So this is n permute r and this is n to the power r. Okay. Permutation, normal permutation without repetition is n permute r, npr, and with repetition is n to the power r. But as you can see on your screen, this is nothing new. This is simply product rule. So even if you do not understand generalized permutation, you can solve this using an application of product rule. Okay. Which brings me to generalized combination. Okay. Generalized combination. Now I am, because there is not much time, so therefore I cannot take you through how generalized combination works and why we are doing what we are doing. Just know that in case of combination with repetition, your answer is n minus 1 plus r, choose r. Normally, if you have n distinct objects and you are choosing r objects from them without repetition, your answer would be n choose r. Normally, there are 10 people, I'm making a group of 5 people. In how many ways I can do that? 10 C5. This is without repetition, NCR. But what happens when there is combination with repetition? For example, you have gone to a shop to buy, say you've gone to a shop to buy ice cream and you want 10 ice creams and the shop is carrying not how many ice creams, how many flavors of ice cream. So what is the difference here? N for generalized combination is not the number of objects. It is the number of types of objects. For example, you've gone into a shopping mall and you want to buy 2 dresses. Now a shopping mall has thousands of dresses. So is it going to be say 5,000 choose 2? No, because you can choose to buy the same kind of 2 dresses. Suppose you buy a dress in yellow and you buy the same kind of dress. Say you can repeat your choice to buy 2 of yellow pieces. Okay. So when you have the freedom to repeat your choice, then it becomes generalized combination. If I say I'm making a group of 5 people, then the question of repetition does not arise. I cannot repeat a person. A person is unique and individual. I cannot repeat. But suppose if I say that I'm buying a cloth, then I can choose to buy 2 clothes exactly the same. So what happens is when you have the freedom to repeat your choice, then that becomes generalized combination. For generalized combination, please remember n is the number of types of objects and r is the total number of choice. Okay. So for example, in the ice cream wala example, suppose you want to buy 10 ice creams and the shop has chocolate, vanilla and butterscotch. So n here is number of flavors of ice cream the shop is carrying. So n is 3 and R is the total number of ice creams that I want, which is 10. So N is 3, R is 10. Total number of ways of choosing is N minus 1 plus R, C, R. Okay. I hope you've understood this. So for normal combination, n is the total number of objects. R is how many I need to choose. Just a minute. छोड़ो क्या है चीनी खराब. अच्छा. আর generalized combination এ কি হচ্ছে? Generalized combination मतलब n is the number of types of objects, not the number of objects, number of types of objects. And R is how many I need to choose. And your answer is n minus 1 plus R, choose R. This is basically your syllabus for my part in the MTA. All the notes are shared. Please get them through your CRs. Please ask them to share the note with you, okay? So that you can.
हाँ बोल बोल क्या अरे भाई मैं इधर आ चुका हूँ, घर में आ चुका हूँ। रुक जा। मैं उधर 9 तारीख अगर रूम दिखा दूँ तो होगा, चलेगा? 1 मिनट रुक जा तू, कॉल में 1 मिनट रुक। जस्ट रुक जा, जस्ट एक बार। ऑन गोइंग स्पीकर, हाँ बोल।
हाँ, एक रूम मिल मतलब हम लोग देख रहे थे ऑनलाइन, तो एरिया ठीक ठाक है, कृष्णापुर में ही है, बगल में ही है।
अच्छा
कॉलेज से वही 2 किलोमीटर है, तो ठीक तो लग रहा है। लेकिन वही है, इसमें बोल रहा है कि 8,000 है और 8,000 ब्रोकरेज लेगा और 8,000 सिक्योरिटी लेगा। ये सीन है हम लोग का अभी।
अम, क्या 3 महीने का?
नहीं, ये ब्रोकरेज 8,000 ले रहा है।
हाँ ब्रोकरेज तो 8,000 ही लेगा ना, 1 महीने का पूरा लेता है ब्रोकरेज।
हाँ वही, इसीलिए तो दोस्त आएगा तो बोलिए, तो हम ही लोग आ जाएंगे तेरा दोस्त के साथ। 3,000 तो फिर साथ में हो जाएंगे हम लोग।
मीटिंग पासवर्ड काम क्यों नहीं कर रहा? 1 मिनट रुक जा तो।
हम्म।
मीटिंग पासवर्ड काम क्यों नहीं कर रहा बहनचोद? व्हाट्सएप लॉन्च मीटिंग, ओपन जूम मीटिंग। ओ डन।
तो काम करना